Differential equations, 2004, question 10a. This is type 1 first order differential equations. So we're going to be looking to get y on its own, in other words solve the differential equation, given that y is equal to 5 when x is equal to 1. So we're going to start by trying to isolate our y terms on the left and our x terms on the right. So we have x squared dy dx minus y plus 4 is equal to 0. So I have x squared dy dx is equal to y minus 4. And then if I divide both sides across by y minus 4 and divide both sides across by x squared, I end up with 1 over y minus 4 dy is equal to 1 over x squared. And then if I multiply both sides across by dx, I now have isolated my y on the left and my x on the right. So I then want to integrate both sides. So I'm integrating the left with respect to y, and the right I'm going to write as x to the power of minus 2, and I'm integrating the right with respect to x. So what are my limits? Well, at the start I know that y is equal to 5 when x is equal to 1, and at the end we don't know anything, so y will just be y and x will be x. So my end limits are my upper limits, and my start limits are my lower limits. So if I integrate 1 over y minus 4, we can see on the top of page 26 that this is going to be a natural log function. And therefore that's going to be natural log of y minus 4 with limits of y and 5. If I integrate x minus 2, I'm going to add 1 to the power and divide by that power. It's up in the limits of x and 1. So then I have natural log of y minus 4 minus natural log of 5 minus 4. And on the right hand side, if I sub in my limits, x to the power of minus 1 over minus 1 is the same as saying minus 1 over x. And if I sub in for x, it's just x. And then sub in for 1. So on the left then, we have natural log of y minus 4 minus natural log of 1. But natural log of 1 we know is 0. So therefore the left hand side is natural log of y minus 4 is equal to minus 1 over x plus 1. And now I just need to change from log form back into exponential form. So again, on the top of page 21 in our maths tables, we can see that if we're changing from logs to indices, then we have to remember that natural log of y minus 4 is the same as saying log y minus 4 to the base e. So therefore a in this formula is going to be e. So therefore that can be written as y minus 4 is equal to e to the power of minus 1 over x plus 1. And then if I get y on its own, just add 4 to both sides. So I have y equals 4 plus e to the power of minus 1 over x plus 1. So we have 5 for setting up our integrand, 5 for integrating, 5 for subbing in our limits, and 5 for our answer. And of course that power there, minus 1 over x plus 1, could also be written as x minus 1 over x.